My name is Cesar Cerrudo, and he's Newman. We will welcome to this talk. We will be talking about the last vulnerabilities in Microsoft SQL Server. Most of them have been already fixed, but we think that it's important that you know all the vulnerabilities. We don't have nothing against Microsoft. I think that SQL Server is a very good product. It's one of the best database servers, so let's start with this. Okay.
Okay. Yeah, this presentation is really kind of the culmination of about a couple months of research by Cesar, kind of black box testing. There's a presentation that goes along with it that really goes into the methodology that Cesar followed to do that black box testing. So we recommend you to look at that as well. This is just a quick outline. We're going to start collecting passwords, looking at some passwords that can be pulled out of SQL Server, and we'll talk about elevating privileges, meaning going from a less privileged user to a more privileged user. We'll be covering how to break out of SQL Server and gain access to the operating system. And then we'll finish up with a denial of service attack. And at the end, we're going to go over some resources and wrap up. And as well, we have a demonstration of a SQL injection tool that Cesar's written that's really interesting in some of the techniques it uses. Collecting passwords is where we'll start. I guess let me start by explaining SQL Server has two modes of authentication. One where you can use your Windows credentials, and that's actually the recommended method that Microsoft recommends you use. There is, however, also a second method, and that's with the SA account, and those are standard logins, where you can create an account and then SQL Server maintains those logins. So now, why is that important? Because if you're using, Microsoft SQL Server uses a lot of processes that run jobs or do other tasks, and they're processes outside of SQL Server, so that they actually need a login and password to authenticate to SQL Server. Now, because they need those login and passwords, and they're run not by a user, but at a scheduled time, they need to store that password somewhere and pull it out. And that's really where those passwords are stored is where we're going to look today and show you some of the places you should lock down and make sure you didn't leave these passwords there. These passwords are actually stored usually somewhere in the registry or in tables, somewhere else. And they're usually, I don't even like to use the word weakly encrypted. They're really encoded using an algorithm that you can't obviously see what the password is. But there's really no secret key to encrypt it. So it's really just the knowledge of the algorithm that's keeping it secret. And just because I went over what I just went over, they're saved with that weak encryption because they need to be pulled out later, decrypted, so they can be used to authenticate. And so the real issue is not that that this is being done. The real issue is that if you leave access control where people can pull that out by default out of a SQL Server, that's where the real problem arises. The first place is in DTS packages. DTS, Data Transformation Services, it's really a fancy way to write a script in SQL Server and to allow it to suck data from one place, manipulate it, and then push it into another place. And a DTS package is really a combination of what transformations you want to make to the database and the connection information. And that's what's important, is the connection information where you can get in trouble, because that connection information includes the username and password. It could be stored, that DTS package can be stored in a number of different places. On SQL Server, in what's called a metadata service. It can also be stored in structured storage files and in Visual Basic files. So the real weaknesses we found were when it was stored in SQL Server or when it was stored in a metadata services file. There's also really two passwords associated with the DTS package, and this is where it can get a little bit confusing. There's a password that it uses for the connection information, and that's the one we're more worried about people getting. There's also a password where you can encrypt the DTS package. So let's just be clear. There's a password that encrypts the package to protect it, and within that, there's also a password that the DTS package uses to log on to the system it's going to pull data out of. When you save DTS packages in SQL Server, they're encoded using a proprietary algorithm, and they're stored in an MSDB database in a table called sysdts packages. Now, the first thing you want to do is, if you want to pull this out as an evil hacker, is you just try to select from the table. And now, permissions to select from those tables are not given by default. So knowing SQL Server and how it works, you have to say to yourself, well, I can't select directly from the table. What I can, the first thing I try to do, though, is go find a stored procedure that selects from that and use that stored procedure to actually select from it. And that works because the ownership chaining in SQL Server allows someone, if a stored procedure and the table are owned by the same people, which all system objects will be, you're allowed to select on that object even if you don't have permissions to it. So what you have here is two stored procedures, SPE Newman DTS packages and SPE get DTS packages, and both of those are granted to public. They're granted execute permissions are granted to public, so all users can execute that. So to uncover the passwords, we're going to show a little demonstration. The first thing you do is get the DTS package data, and this is what we're going to show here. I have to get the right window up now. So the first thing you do is we're going to set user to guest so that we're a non-privileged user.
No, I wanted to say that all the script the user already connected is a sysadmin user, but in every script we will set to a low privilege user with the set user instruction. So we will demonstrate that the lower privileged user can execute that commands.
So execute this, and you see that we're now the guest user. And then we call enumerate DTS packages, which actually gives us a list of all the DTS packages that are saved in our database. And using the information we pull out of that, such as the name, the ID, and the version ID, that's parameters we have to feed into the get DTS package to actually pull out the password. So I just cut and pasted those earlier. And then I execute this, and what I get back is this package data. And so now, still looking at the package data.
I want one second. These two steps are only necessary if you are exploiting this raw SQL injection. If you can log to the server, then you can log with Enterprise Manager. Just open the page, the package.
Right. So you can either get this package data here, or you could just simply go to Enterprise Manager, and this is the management tool for SQL Server, and you can go into Data Transformation Services, and when you do Properties here, or you design package, this brings up the package. It takes a minute. And then you go into Properties, and right here is the password, and it's in asterisks there, but if you do a memory dump of it, you'll see that the password's actually in memory.
You can read the password. That was fixed in SQL Server 7, but right now you can still read the password from memory.
So that's how you would get the password decrypted without having to understand the entire algorithm for how it's encoded. Okay, so once you get that DTS package, if you have access to that database, you could simply use Enterprise Manager. If you don't, if you're using it through SQL injection and pulling that package data back, you just insert it into your own SQL instance. You'd open the DTS package through Enterprise Manager, just like I showed, and then you would be able to read that out of memory. Fix for this is to use strong passwords. Whenever you save a DTS package, you can use a password to encrypt it, actually. And so you want to choose a strong password because it can also be brute force, so you can't use an easy password on that. Another place that DTS packages are saved is in the metadata services. This is actually saved in the database as well, but in a different set of tables. The connection password is actually saved in clear text in a table in the MSDB database under RTBL DBMB props. And it's actually saved in a column called COL11120. So it's actually, it's probably been there for years. The thing is, it's buried so far down that probably no one has ever noticed that there's public permissions to select from this table. So in this case, it wasn't even, you didn't even need to find a stored procedure. It was really just permissions have to be revoked from that table. And this is, let me go ahead out here and show you once again. I have to find that. I already did this one. And once again, that's the actual password that I entered when I created that DTS package. And I'm the guest user right now. So the recommended solution for this is to revoke that permission from that table. It's also recommended you don't even store it in here. Actually, Microsoft as in Service Pack 3 has actually removed this functionality where you have to go dig pretty deep into some properties and turn this on if you really wanted to use it. So it's best just not even to use this setting and to save it somewhere else encrypted with the password. Replication is another source where you need to enter a password so that if I'm replicated with a remote server, I need authentication credentials to connect to that remote server. So where's it going to store those? Here's one instance of if you log into Enterprise Manager using SQL authentication. You create a subscription. A subscription is basically saying, I want to pull data to me. There's a publisher that publishes the data, and there's a subscriber who gets the data. If you create a subscription and then you use Windows Synchronization Manager to synchronize that, what it will do is take the username and the password that you're currently logged on with, and we'll save that in the registry. It will save it in the registry encoded so that later on, when it needs to synchronize, it can just pull that value out and use that to log on to the remote server. And this registry key is actually created with read permissions.
To everyone.
What's that?
Any user can read.
Exactly, yes. The user can read. This is actually the registry it's stored under. It's stored under HKey local machine, and actually the name of the key that it's stored under is dynamic. It really depends on what your publisher's name is. So depending on what the subscription name is and the publication name is how it will create it. And we'll show you an example. And it's actually stored under the value subscriber encrypted password binary. Here's actually the SQL command. In the master database, there's an extended store procedure called xp_regread that can be used to read values from the registry.
And have the default permission to every user.
Right. Execute permission is granted to public on this function by default. So we'll go out there. We'll go out to SQL Server again, and I'll have to search around and find the right script again. Here it is. These are big enough for everyone to see? I'll take that as a yes. I don't see. What's that? The color? I don't know how to change that.
In properties.
Is it that big a deal, or? Okay. Sorry. I'll next time I'll make sure that doesn't happen. I'm not sure. So we're the guest user now, so then we go in and we try selecting, and I know ahead of time that
The password is decrypted with like extended store procedure, so it's not necessary to know the encoding algorithm, so you have to only use that extended store procedure.
Right. So this is a little tricky. This script doesn't work straight out of the box. So what you do is you execute this, and it pulls the value back. This master XP REPL help connect, that you do need administrative privileges to run. But what you do is take the value you got back from reg read take it to your own local MSDE version and run it there. So you kind of have to do this in 2 steps, really. So you don't have to figure out the encoding algorithm yourself. It's really here in the XP REPL Help Connect. So what do we do for this? Once again, apply Service Pack 3, which I think actually a lot of people have done over the last couple weeks. When we actually prepared the presentation, I had a feeling that most people would not have applied it, but that's changed a lot. And now in Service Pack 3, it does not save it in the registry anymore. So every time you want to synchronize, it's going to ask you for the password, the username and password to use. As well, it's recommended that you revoke execute permissions from XP regread. I think this is probably the biggest hole in SQL Server right now, is that public permissions on XP regread exist in there. And I could, on a default installation, I could pull out the passwords out of the LSA secrets area, out of the SAM database, all that, because it's running under a local system. And as well, there's how you do it from SQL Query Analyzer. SQL Agent, that's kind of the scheduling engine for SQL Server. It runs as a separate process, and it does maintenance, such as I want to do a backup every midnight, or I want to dump the database every 4 hours, the transaction log, something like that. So you need to configure it to use a password to log into the database. So obviously you got to enter that, and then it's got to be stored someplace. So when you do set it up to use SQL Server authentication, it does require a sysadmin login and password, although I've heard rumors that that's not true in Service Pack 3, but I'm not 100% sure about that. But it's usually a sysadmin you use you have to enter to connect to the SQL Server. The password is saved encoded in the LSA secrets area, and the SQL agent is typically run under a Windows NT administrative account because it has to access that LSA region, and that can only be done by a Windows administrator. So now permissions on the LSA secret is locked down very well. Now if you're logged on to SQL Server, it's going to be hard to get there, except that there is a stored procedure which calls an extended stored procedure, which will retrieve this for you. And this procedure is actually executed to public by default.
I have the example to show.
Okay. Yes. Is that commonly known on the net to grab that script? Actually, it is. It's there's keys out there on the SQLsecurity.com website, or there's sample scripts. I haven't seen one that's fully like a PW dump. There's nothing like that. What it is I've seen scripts of how to pull one key out. So you'd have to be smart enough to paste all those together and figure it out. So the capability's there, but I haven't seen a tool that does it. Which one am I looking for?
SQL Agent passwords.
No. I'm sorry, bear with me just 1 second.
The password is saved in code, but you don't know to. It's not necessary that you know the algorithm, because there is a function in a DLL that you can code a small C program and decode the password.
Right, so there's your password, but notice that it doesn't look like anything that any of us would understand. But what you could do is take that function, pass it to something. There's a guy in Russia, Martin.
Jimmers.
Yeah, Jimmers, I guess is his handle. He actually figured out that in the SCM.com.n.dll, there's a decrypt function. You pass this string into there, and it will decrypt it for you. That's basically the same thing that SQL Server is using to decrypt it. So that's how you would decrypt.
There you have the URL to download the program.
Yeah, that's a C program to decrypt it.
He helped me to decode the password.
So the fixes for this, once again, are and really the fixes for all this is to use Windows authentication. Sometimes it's not always possible because if you have a firewall, you're going to be blocking port 138, 139, and you're not going to be able to. But if you can, it's really strongly recommended you use Windows NT authentication. Revoke execute from that SP get SQL Agent properties. That's the line to remove it. And apply Service Pack 3. And in Service Pack 3, this stored procedure won't return that field with the password for you unless you're a sysadmin.
Okay.
Okay.
Let's see now some other ways to elevate privileges. Okay, global temporary stored procedure. They can be created by any user. Also, they can be executed by any user, can be altered, dropped, etc. by any user without restriction. This means that if any user, a username is shown, create a global temporary procedure, then any other user can do whatever he wants on that global stored procedure, and the user who create the global procedure can set permission on it. So thinking with a hacking mind, then this is a good opportunity to insert Trojan code. Okay, how the Trojan code could be inserted? So first you have to do is to search on sysobject system table on tempdb database. You have to look for the names of objects that start with double sign number. No.
Pound sign.
Double pound sign, okay. Because the global temporary procedure always start with a double number sign. Okay. After you find one, only you have to do is just alter the store procedure and insert the code that you want. Then you only have to wait for a user. Probably the user who created will execute it. So if the user has higher privilege, then the attacker will be able to elevate privileges. Okay. This is not considered a vulnerability by Microsoft because they work as designed and as documented, but in documentation is not explicitly told that the danger of using global temporary procedure, and also isn't expressly told that any user can alter them. So in my personal opinion, this is a bad design. Okay. I know that this kind of objects are not very commonly used, but the risk exists, so you have to avoid using them. Okay. Now let's see some background on how SQL Server check permission on objects. Okay. SQL Server, if the same user owns a view, a store procedure, user-defined function, or a trigger, and all the object references inside the store procedure or the view, etc., then SQL Server only checks permission on the main object, not on the underlying object. This is called ownership chaining. This means that, for example, if a user create a store procedure, then if all the references of objects are also owned by the user show, and then another user, Mary, can execute that store procedure, then Mary will have access to the underlying object, no matter if Mary have permission or not on them. This you can see this all the time when you are using system store procedure. For example, when you are using SP password, you can change your password, so you are updating sysx login system table, but you can update sysx login system table directly, but you can do it using SP password store procedure. That is a valid example. Okay. Okay, if SA login is the database owner of any database, then the SA login is mapped to the DBO user. Also, all users that are members of DB owner role can create objects and designate them as owned by DBO. This means that all the user members of DB owner role can, when creating object, can use the DBO prefix. Okay, but what happens if a view or store procedure could be another object, like I said before, like triggers, user-defined function, references object in a different database. The view or procedure is owned by DBO. Sorry. And the object is owned by a different DBO in a different database. Let's see an example. Okay, in this example first, we will add, we are logged as a sysadmin user. So we will add a test user, then we use the Northwind database, then we will grant the user access to the database, and then we will add the user to the DB owner role. And then we will set the connection to that user. Okay, here we will create, being the user test, we will create a store procedure named test. And that store procedure will select all the rows from the sysx login system table. This shouldn't work, but let's try. Oh. So we are only a DB owner if we already accessed sysx login system table. Is it clear, the example? Okay. Why the previous examples work? Because SQL Server performs as access control in the next way. First, it checks permissions on the store procedure. Then, SQL Server gets the SID of the user in the current database that owns the store procedure. In the example we see, the user is the DBO user, and the SID will be one that is the SA SID. Okay. And then SQL Server compares the SID that already have with the SIDs of the owners of the object referenced in the store procedure. And because the SID of the owner of the store procedure matches the SID of the owner of the object referenced in the store procedure, the example that we previously see works fine. Okay. The access control are not well designed to handle when a user is member of DB owner role, but is not the DBO user. Also, the user also is not a member of sysadmin role, and the user create a store procedure using the DBO prefix. But the user doesn't have permission on the object referenced in the store procedure. Like I said before, this also applies to view, triggers, and user-defined function. This means that any DB owner can impersonate SA when SA is mapped to the DBO user. This also works when using Windows authentication, because if you are using Windows authentication, SA login could be a database owner. So you will also be vulnerable if you are using Windows authentication. Okay, let's see now an exploit for this. In this exploit, we'll be elevating privilege, and we'll be start being a DB owner user, and we'll be finishing being a sysadmin user. Okay, this starts as the same as before. Here, with this vulnerability, we can use that vulnerability to add a DB owner use directly using system store procedure, add the user to a sysadmin role, because in the system store procedure is checked for ownership, for role ownership. So we can bypass that checks. So we have to, what we can use is exploit the SQL injection vulnerability in SPMS drop retry that was discovered by Chris Anley some time before. Okay, so we need to have write permission on sysx login system table. So because we need to update a field so we can be sysadmin. So the first we do is to create a view, so we will have write permission on sysx login because we will have write permission on the view, so because the ownership chaining, we will have write permission on sysx logins. But we won't be able to write directly, so we will use sp drop retry to write to sysx logins table. But first, it could happen that the SA login is not mapped to the DBO user. But that doesn't matter because we can exec this, and we exec this instruction. So we update the SID field with value of 1. That means that that user will be the SA login. So no matter if SA login is mapped to the DBO user, we can add it. Okay, after that, we only have to update the previously created view with a value of 18 on the X status field. That value means that we are sysadmins. So let's try the example. And at the end, we will be erasing, we will be dropping the view and return all back to before the hack. Okay. Oh, sorry. I forgot to mark. Okay, ahí está. There is the user test is now member of, you can see there, role membership is checked, so if the user is member of sysadmin, then that rows are displayed. The same exploit could be done by the same exploit could be done by user member of DB security admin role, DB data writer role, DB DDL admin role. So, because DB security admin role can grant write permissions on any table. So, a user member of DB security admin role can grant itself right permission on the table of his choice. And a user member of DB data writer role has right permission to all tables. And a user member of DB DDL admin role can alter object that doesn't own. But to successfully exploit this, the user member of that role first must become DB owner. After become DB owner, then they can become sysadmin. Okay. Here is the example. In this example, we add a user, then we add a user to the DB security admin role. Then we set the user to the new created user, and then we update the First, we must grant ourselves right permissions, update permission on sysuser table. So we will be able to update the roles field on sysuser table with a value of 1. That means that we'll be elevating privileges to DB owner role. We can see that the user is now DB owner. Here you can see, we check for ownership, for role member, if he's member of the role DB owner. So, like it is member, then we can see it here. So that was when the user is member of DB security admin role. So one time the user becomes DB owner, then the user can use the previous exploit to become sysadmin. Okay, now it's almost the same. If the user is member of DB data writer role, it just can write directly to sysuser system table. Of course, always using SPMS drop retry. Let's execute this. Now again, you can see that the user has elevated privileges. Okay, and last, when the user is member of DB DDL admin, the user must find a view in which the user has update permissions, because the user is member of DB DDL admin role. It can alter it no matter if the user doesn't own the view. So what does here is it alters a view that is by default in Northwind database, and insert a query that select all the rows from sysuser system table. After that, it only have to update that view to become DB owner. Here you can see that the user has successfully become DB owner. Okay. Okay, the fix for this, after you apply Service Pack 3, is there is a new server option that is called Allow Cross-Database Ownership Chaining. This option is disabled by default when you are installing Service Pack 3, but during installation you can enable it. There is a message that says that it is not recommended to enable it, but never say because the reason because it is not recommended. Okay. Also, the option can be enabled or disabled later using the SP configure system store procedure. That command is to enable the option. If you pass a 0 instead of 1, you disable the option. Also, the option can be set per database. Using the SPDB option, store procedure, you specify the database, then the property, and then the value to enable or disable. Okay. Also, if you haven't applied Service Pack 3 yet, you can start revoking execute permission on SPMS drop retry. But if you already have applied Service Pack 3, then SPMS drop retry is not more vulnerable to SQL injection.
Does that does that make sense to everybody? What exactly is going on? What it's doing is, and what it's a good case for is if in SQL injection or in a SQL web application, you may have set up a user and said, well, I don't want this user to be SA, which is a good practice, so I create them as a database owner. And what this is a way for somebody using SQL injection to become from DB owner to an SA. So
I don't know. Any have some question? Maybe I wasn't very clear.
Did everybody kind of understand what was going on there? Okay.
Thank you. Okay, let's see now. Okay.
He's asking which, how are the passwords encoded? Which passwords are you referring to? At the beginning? There was a couple of them. We can go back.
There are different algorithms. You are referring to the algorithm. I didn't reserve the algorithm because there are many easy ways to get the password, so I don't want to lose time on that. Sorry. Okay, let's see now how we can get for the system. Okay, after an attacker, because sysadmin, okay, the game is over because the attacker has complete control over the database. But the attacker still needs a way to gain control of the operating system. If there is some scenarios where XP, CMD shell, and its DLL has been removed, that you must find another way to execute command over the operating system. So what you can do is exploit some buffer overflows that some extended store procedure are vulnerable to buffer overflows because they don't properly validate the input data. In this case, the extended store procedure named XP make web task has two parameters, file and TPLT, that are not correctly validated. So if you pass a long string to any of these parameters, then there is a Unicode stack overflow, and you can exploit that overflow to execute command of operating system. Okay, let's see an example. What is time? We're having time?
We have plenty of time, yeah.
Okay, now we're going to bypass a very long string in the file parameter. Now you can see there is an access violation. If you run Visual C++, we will be able to see how we can overwrite the saved return address. Okay. I know that Unicode buffer overflow are difficult to exploit, but are not impossible. Okay. Here you can see that we have control of the execution of the problem, because we pass a large amount of x. There is the x value of the x letter, that is 58. Okay, now let's see the other overflow in the TPLT parameter. And here again, you can see the same.
Well, go ahead.
Can you repeat?
I mean, what does that give you the capability to do? I don't think he's demonstrating the exploit. He just showed that he overwrote.
I'm showing that it is possible to exploit that, not showing an exploit, just showing.
That 0058 showed that we've overwritten the stack pointer, so you can inject code in there and open a command line and execute a command.
I know that Unicode buffer overflow are very hard to exploit, but if you saw other talk, you probably saw technique to exploit them. Okay, after you apply Service Pack 3, the overflow is fixed. Okay, but this doesn't represent a big risk, because the XP make web task can only be executed by member of sysadmin roles, but like I said before, sometimes you have to find another way to execute command, and I think this is a valid example. Okay, now let's see OLEDB providers. If we use the open roasted and open data source functions, we can execute queries against OLEDB providers. So I decided to try to exploit an old hole and to use the shell access function. So if we specify the SHET OLEDB provider 4.0, then let's see what happened. Okay. Well, this we have a last minute problem, so ignore this. No, it's okay. Okay. This is not supposed to work. There is a last minute problem. Sorry. The SHET 4.0 Microsoft Access Provider is blocked. There is a default option that is called the sandbox mode that is blocked by default. So you can use the shell function outside Microsoft Access. If you try to use like there, it won't work, because the SHET sandbox block the use of the shell function outside access. So, but then if we try again using an older provider, the 3.51 provider, then we are able to use the shell function because the SHAET sandbox fails to block that provider. So we have another way to, sorry for not being able to show it, but there was a problem here. But you can try it at your home or here, it will work. I'm sure it will work. Okay. Well, like I said before, this is when we use another provider, it's not blocked by the SHAET sandbox. Okay, this bug is not particularly related to SQL Server because this bug is related to the SHAET sandbox, which fails to block the shell function when used outside access, outside Microsoft access. So at this moment, there is no fix available yet. Okay. Sometimes it's very useful to know under which Windows account SQL Server service run as. So this helps an attacker to determine what privilege will gain over the operating system when executing command, when exploiting buffer overflows. So to do this, we can use the bug in the OpenRoasted function that when the function is invoked with no parameters, okay, when the function is invoked in this way, then you will be able to see under what account is running SQL Server. In this case, the system account. This is not a big deal, but this is very useful when you are exploiting SQL injection because you can do the same using the XP read extended store procedure, but if you're exploiting SQL injection, it's very difficult to get the result back. So in that way, it's very simple to know under which account is running SQL Server. And sometimes, if there are multiple instances, you will need to provide one instance name to know the account on what it is running. Okay, after you apply Service Pack 3, I think it is fixed. The Windows account is not more returning in the error message. Okay. Some questions?
Any questions on that, or everybody falling asleep yet? Denial of service attacks. This one is actually pretty quick, but so if a hacker can't do anything else in your database and he's just frustrated, I guess he'll go ahead and just try to bring it down. And really what this one is based on is temporary tables, where there's a tempdb in Microsoft SQL Server and there's a guest user in it, so everybody really can get access to that and can create tables, create temporary tables, and you can't remove that ability. So this query down here that we're showing will actually do an endless loop and will create a table and we'll insert rows into that table. And what that will do is just grow and grow and grow until it consumes 20 gigabytes on your hard drive. And at that point, the SQL Server will likely fail or something really nasty will happen. So,
also, if the page file of Windows 2000 is in the same disk, will be more problems.
Oh, yeah, okay. So we'll just show an example of this. So once again, we'll just set guest. So we're a non-privileged user. And then actually what we'll do is go out here and look at the disk size. And we see there's about 4.3 free space. And then we will execute this command and let it run for a minute or two, and it's just sitting there loading the table and loading it.
The time to fill the hard disk will depend on the processor power and the disk capacity.
So now we'll just look at the size again. 324. I don't know how much it ate up there. Let me see if it's different.
No, it depends on the processor power. If you don't have much power, it will be more slowly the growth.
Yeah, so it's gone down a little bit now, because before it was 432, so now it's 431. So it's eating up space, so I'm not going to leave
We can let it run, so at the end we can.
Oh, you want
we
it?
can see again.
Well, I'm just going to cancel it, because I don't know how it's going to affect. I don't want my laptop crashing.
Okay.
Why is this doesn't look like even a threat, really. I mean, it's just you let somebody log on to a system and give them access to facilities, they can use them. So you shouldn't give people access to the system if they don't trust.
I don't know, but you should be able to restrict these things, because any user can do this. Any user can fill up your hard disk. I don't know.
Yeah, this is a guest account. If they have any interactive access or network access through the query analyzer, they can write this code and they can virtually take their SQL box down. That's what I'm hearing, but I'm not a SQL guy.
Exactly, yeah. So if you don't have to be an administrator. So yes, can somebody that has no access to your database bring it down? This is not what we're saying. But can a non-privileged user bring your database down? That I would consider that a vulnerability. As well, if your competitor can do a SQL injection and decides, well, I really want to bring a site down, I think that's a great example of how it could be pretty dangerous too, SQL injection.
The main problem is you don't have a way to restrict this. So any user can do this, and you can do anything to prevent this.
I'm not pushing back on but seriously, on the injection attack, if you have an application that needs to use temp tables and is prone to an injection, who could stop that?
But it doesn't need to use temp tables. Anybody could do this.
But you can restrict access to table using store procedures. You can restrict using store procedure, and the user won't be able to insert directly on table. But here, there is. Okay.
Currently, there really is no protection against this, so you have to make sure you don't have SQL injection, or you have to trust all your users. Microsoft apparently is going to add something in Yukon to prevent this. The workaround, obviously, is to put some kind of an agent, to use your SQL agent to alert you when your tempdb starts growing to some ridiculous size.
This is the best.
Yeah, I mean, you saw how fast it was going. It wasn't too fast. It might take a couple hours to fill up, so that should give you enough time to react before it starts crashing things. I mean, it
Can
should
you
be
repeat
hitting.
the question?
How much utilization? The question is, how much utilization does that denial of service do? I haven't done any performance metrics on it.
Processor utilization.
Yeah,
Sometimes it goes high, very high.
The good news in this case is one disk, so it's not outbound. The bad news is that on a system where it really matters, it's more disks.
And the cache or something like that.
It could be worse.
So now we'll
Okay.
just do some resources,
Okay.
conclusions, and then show you the
Okay.
utility.
For recommendation, we have the next. Okay, this is very known, but you must keep your SQL Server up to date with hotfixes. Also, it is very recommended that you use Windows credential for authentication. Also, never enable cross database ownership, because it's very dangerous, like we saw. Also, you must run SQL Server service under a non-privileged user and restrict that user rights. on the operating system. Then you can set SQL Server Agent alerts on critical issues. So if something wrong happens on your server, you will get a response back from the server.
You ought to, as well, other recommendations, run your periodic checks on system and object and non-system objects, make sure permissions haven't been monkeyed with on those. Audit yourself as often as possible, because some of these can be used as a backdoor to put something in there and then come back later. And as Cesar says, pray a little bit.
It's a shock.
Resources to stay patched, Microsoft.com. There's a security and a SQL directory out there. You ought to check those out every once in a while. MSSQLsecurity.net, there's a mailing list out there that you can go join, and it's targeted specifically just for SQL Server, and it will alert you for those. There's a white paper out there written by Cesar, manipulating Microsoft SQL Server using SQL injection, and you can go down.
You can use that technique to exploit all this stuff, and you will own a server.
And as well, there's other security information out there on my own website, appsecinc.com, and Chip Andrews has a good website, SQLsecurity.com.
Okay, as a summary, we can say that there is a huge security improvement in SP Service Pack 3, mostly as a result of independent security reserve work, but Microsoft did a great effort too. Okay, there is some hosts without fixes yet, like we saw, and SQL Server 7 seems to be forgotten. There is no fixes yet for SQL Server 7, also for Microsoft Data Machine. So, okay, you must buy SQL Server 2000. Okay, if you use SQL Server authentication, sooner or later you will get hacked. So you must avoid use SQL Server authentication.
That's what Microsoft recommends that as well. So.
Okay, now let's see this tool. This is a new tool to exploit SQL injection. This tool uses the techniques described in my paper called manipulating Microsoft SQL Server using SQL injection. Okay, we don't cover that technique here because we don't have time, but you can read the paper. Okay, this tool allows to get the query result back to your SQL Server. So you only have to have a SQL Server box, then you have to find a web application vulnerable to SQL injection, and then using the tool, you will be able to get the result back to your server. This works even if the query results cannot be returned to the browser. There is some scenarios when you can get the result back to the browser. So this tool will work. Okay. Also, this will work only if outbound connections are not blocked at firewalls, but 80% of sites vulnerable to SQL injection don't block outbound connections, so it will work most of the time. There is another way to bypass firewall filters, but I plan to add them for. Okay. Also, this tool allows you to set arbitrary outbound connection ports, so you can bypass some filters. So you can start trying some ports to see what happened and then bypass the filters. Okay, now we will see a demo. You can download the tool from the last version of the tool from that site, from Aaron site. Also, I think the tool is in the CD, Black Hat CD, but I recommended you to, in the next week, to download it again to get the last version.
It's probably not up there yet. It's probably check Monday. It'll be up there. So.
It is still in beta, so I haven't much time to. Okay. First, you have to set your SQL Server properties, like the SQL Server name, the login name to authenticate to your server, the password, the port that will be used, and there is the max amount of rows returned when we execute a query. Okay, but
This is a little confusing. I think Cesar wrote it so he doesn't see. It's very logical to him, but
maybe yes,
top,
if
the top SQL server is actually your own SQL server. It's not the SQL server you're attacking. You put a local SQL server, the web application is going to log into the remote SQL server and pass the results back to that your SQL server. So that's what you're entering at the top.
yes, if you read the paper, we understand. Okay. No, but no, not him. I'm referring to you. Okay. First, you must find a website vulnerable to SQL injection. This is very easy. There are a lot of sites.
What we've just done is created a test ASP page where
now
you
we
enter
have
something.
an input box, so we try a single code and submit the query, and we see an error message. But here the query is using a parenthesis, so we have to add a parenthesis to be able to inject code. So we add a parenthesis and comments, and now we don't have the error, so we are able to execute code. So here in the application, we already have the method that the web application it is using to submit the data is the post method, the HTTP post method. So here you enter the URL, then select the method, the HTTP method, and here you put the post data. You must complete the post data with less than sign with 3 asterisks and greater than sign. In that place will be injected. Sorry. In that place will be injected the code. So you don't have to do anything. Just find a web page vulnerable, and then complete that field. Okay. After that, you only have to click go, and it will it will get the linked servers. Okay, that information that it is showed is from the SQL server on the vulnerable website. So we are able to get the data back to our server, and now we are seeing that data. Okay, we can see the linked server in the SQL server that we are attacking, also all the database, and here we can see the version, also the login name used by the web application to log in the database, and the username of the current login. Also, it is shown that if the user is member of DB owner role, and if the user is member of the sysadmin role. Here it's very confusing because we are in the same server. Okay, but this is the attacked server. After that, you only have to select any database, and then click list tables, and you will get all the tables. Okay. After that, you choose any table, and click list files, and we'll get the file of that table. And finally, you choose the files, the fields that you want to retrieve in a query, and just here it is build the query, and just click here, and we'll get the result back. That table has no.
Do something from Northwind.
Yes. here we'll get the table from NotWin database, territories table, and all the information from territories table. Okay. So now you have all the table content. You can cut and paste, and you have the data. Okay.
This particular exploit is dealing with the fact that the code has been written incorrectly. It's not fixed with any service pack. Is that correct?
Can you repeat it?
This, he's asking, this works because of a coding bug, a SQL injection bug, and it has nothing to do with any service pack.
No, this is not fixed in any service pack because in the paper it is explained. It used the open browser function with the SQL OLEDB provider that is allowed to all user to use it. So any use, no matter which login the web application used to authenticate, you will be able to do this. Of course, restriction permissions on tables on databases will apply. If the user don't have permission in some tables or databases, you won't be able to get that data.
Okay. Thank you.
Okay. Okay, well, yeah, sometimes if the firewall is well configured, you have to block all connection. Then, okay, because it is connecting back to your server. What it does is inject code, exploiting SQL injection in the SQL server of the web application. That it issue an outbound connection to your server and bring all the data to your server. So if the firewall is blocking outbound connection, you can avoid this. But there are many ways to bypass that.
I think we're almost done.
Okay, some question?
I pictured this. I mean, if you take that SQL box, you have to compromise. What's to stop you to run this on the box itself?
What did he say? Can you repeat the question?
What? Right. What's to prevent somebody, if you compromise that server, from running this on that box? I don't know if I understand the question.
This
This information gives you the capability of posting it across to a SQL box sitting locally. You're saying a firewall problem would stop this. I'm saying either compromise another SQL box or create another instance that you just port this to.
Okay.
And you do the same thing.
Okay. Yeah. If there's
It's a comment more than a question.
right. There's OLEDB providers which are specifically designed to go through a firewall. I think you won't have a big problem with it anyways, unless somebody's really smart with their firewall.
other question? Okay. Yes.
No, well, for this, yes, but this is a SQL OLEDB provider. There's also a number of other providers that will use different protocols to connect back. So you could do this over a number of different protocols.
You can use another OLEDB provider that will use a proxy, and we proxy the connection using RDS. So you can bypass the firewall if there is a proxy near in the DMS. So there are many ways of doing this. Another question? Okay. Okay. Well.
Thanks
that's
for
all.
coming.
Thanks for being here.
I think we're exactly. It's like.